Perspective matters, and when we're talking about trig ratios, the angle that you're using determines which sides are opposite and adjacent. Hypotenuse always stays the same, but if you change the angle that you are using to determine the opposite and adjacent angles, there's some interesting relationships that can pop up. Let's look at one of those right now. So first off, let's start out with the fact that we know that alpha plus beta plus my 90-degree angle all have to add up to 180 degrees. So based off that, I know that whatever alpha is, it's just going to be equal to 90 minus beta. Alpha and beta are complementary. They both add up to 90 degrees. Let's go ahead and set that aside for a moment. And then I'm going to use alpha as my angle to create my trig functions first. I'm going to go ahead and label these different sides just using the letters A, B, and C. And now I'm just going to pick kind of a random trig function. All of them will have this same property, but I'm going to use tangent to illustrate it. So tangent of alpha is equal to the opposite side, A, over the adjacent side, B. Now I'm going to do the same thing, except I'm going to do it with respect to my other angle, beta. And so tangent of beta is just equal to the opposite side, B, over the adjacent side, A. As it turns out then, I know that cotangent of beta is just going to be equal to the reciprocal, or A over B, which is the same as tangent of alpha. Well, in that case, I know that tangent of alpha is equal to cotangent of beta. I know that alpha is really just equal to 90 minus beta. So what we wind up with here is that if we take one of the angles, so in this case alpha, and take a trig function of it, tangent, that it is equal to the reciprocal of the other angle. So if I had sine of alpha, that's just going to be equal to the reciprocal of sine, cosecant, of the other angle, beta, which once again we can rewrite as sine of alpha is equal to, and I kind of did it in the other direction, but cosecant of beta is just going to be the same as 90 minus alpha. Again, we know that alpha plus beta equals 90 degrees, since the 90-degree angle there took up half of the 180 degrees. And lastly, we could do the same thing with cosine of alpha, and I'm just going to do, I'm not going to write the secant of beta, I'm just going to write that secant of its complement, or the other angle, which is 90 minus alpha, or beta. And so what we wind up with here is these relationships where if we already know one of the trig values, finding the other one is relatively easy. It just reciprocates those values. What I'm trying to get across in this video is that when you're talking about a single triangle, there are two angles which can provide different trig functions, but they're going to be very closely related. They're going to have the same values, you're just going to change the positions. The opposite side becomes the adjacent side becomes the opposite side. That hypotenuse always remains in the same place. If you can keep that in mind when you're drawing them, what that allows you to do is have a little more flexibility in your solving.